Guys, if you're watching this video, it's because I thought it would be good for test corrections to be made. And if you complete the video along with the worksheet that's provided in class correctly, you will earn a 10 out of 10 on a test grade to be averaged in with your other tests for the marking period. So number 4 was a frequently missed question, and it asks you about exponential decay. We know that an exponential equation can be rewritten as a times b to the x power. Now, if they're talking about exponential decay, they're looking for b to be between 0 and 1, non-inclusive. And b is always whatever is being raised to the x power, or any variable. So when they ask you about exponential decay, a lot of people automatically chose 3 because they looked and they saw 1/2 was being raised to the exponent negative t. However, this power, this exponent of x, is positive. So we have to manipulate this a little bit. In the unit, we learned to break apart bases by using the power rule. So this can be rewritten as 1/2 to the negative 1t, and we can bring in that negative 1 exponent and get 1/2 to the negative 1 to the power of t. Now, if you put that into your calculator, you'll see right here in this top line that 1/2 to the negative 1 power is 2. So even though it appears that your base is 1/2, when you rewrite it with a positive exponent, the value of b is 2. Since 2 is greater than 1, that's not exponential decay. If we go on and try 4, 4 is very similar. 5 to the negative t. No one chose 4 because they said, oh, 5 is greater than 1, so the value of b does not indicate decay. However, we can break it apart just like choice 3. We can make this 5 to the negative 1 raised to the t power. And again, just like the last problem, if you put that into the calculator, 5 to the negative 1 right here in the second line is equal to 0.2. So now we can see our b value is between 0 and 1. The answer is choice 4. Another frequently missed question was number 5 was frequently missed. When we solve exponential equations, we have to have a common base. So I need to rewrite this 1 as 3 to some power. I'm going to rewrite 1 as 3 to the 0 power because anything raised to the 0 power equals 1. So now if I have the same base and these two pieces are equal, that means the exponents must be equal. Cross out the bases and set up an equation setting the exponents equal to each other. Add 3 to both sides and you get x is equal to 3. The next frequently missed problem was number 7. A study of the annual population of the red-winged blackbird shows the population can be represented by this. Now, an annual population is represented by b of t, so the annual growth rate is 1.16 to the t power. Let's keep reading. T represents the number of years since the study began. In terms of the weekly rate of growth, so they want me to make this a weekly rate of growth. The population can be approximated by, okay, well, let's see. If I want to make this a weekly rate of growth, weeks occurs how many times per year? 52. So if I make this 52t, how many weeks are in a year? 52. I'm going to try and make this expression a weekly rate of growth by subbing in for t. I don't know what t is, but if I solve for t in the equation created, t is equal to w over 52. So I am going to replace t in my equation with W over 52. Now, that's one way to represent weekly growth rate. But what we need to do is figure out which one of these choices works. Right now, you can cross off choice 4 and choice 3 because they don't have the proper exponent. But let's make sure that 1 or 2 actually works. Just like we did with the first problem, I am going to manipulate this as 1.16 to the 1 over 52 power to the W. Basically, all I did, in case you didn't follow along there, was rewrite this as 1 over 52 times W and bring the 1 over 52 inside. If you put that into your calculator, 1.16 to the 1 over 52, look at the last line of my calculator, is approximately 1.003. So this is 1.003 to the W. But there's another problem. That's not on this multiple choice question either. So we know what W is equal to. We set up an equation earlier. In terms of the number of weeks per year, use this equation. W is equal to 52T. So the answer is choice 2. Just as a side note, I want to just change the fact that I wrote rate up here. These are growth factors, okay? Growth factors. So please note the difference. Growth rate would be the percentage increase, but the growth factor is the entire parenthesis, okay? So just so you have that clarified. All right, number 8 was also frequently missed. If you look at 8, it says which which choice is not correct based on this equation about the ownership of a car. I would hope that you could cross off choice 3. Choice 3 is referring to the initial value, and the initial value of anything with an exponential function is a. In terms of this equation, a is right here, 32,000. Choice 4, I would hope that you could also cross out. It's a little bit more to do than choice 3. The value of the car 1 year after it was purchased was 25,920. Well, in this equation, it says T months. T months. So there's 2 ways you could do this. One, you can make months M instead because you're used to working with M for months from our other problems. And then if they say 1 year, how many months are in a year? 12. So you could sub in 12 for your exponent. If you want to leave it T, that's fine as well. Now, if you plug that into the calculator, I have it done for you already, you can see that that value right here, this top line, is equal to 25,920. So choice 4 is not correct. Is correct, but not the answer because they're looking for what's not correct. Now, the other way you can do this to figure out whether it's choice 1 or choice 2 is to rewrite the expression like we've done a few times today. If I change this to 32,000 times 0.81 to the 1/12th m and rewrite that exponent, I can get a monthly growth rate. Okay, so I'm just going to slide in the 1/12th. If I do that, I get 32,000 times 0.98 to the m, which looks like this in the calculator. That's why I'm choosing 0.98. It's my second line. So all I'm doing is rewriting the equation to see if that helps me out. Now, if we do that, my choices are the car lost 19% each month, or the car maintained 98% each month. Well, this 0.98 is less than 1. That's letting me know that the car maintained 98% of the value, less than 100%, 98% of the value each month. So that works. Choice 1 is the answer. If I maintained 98% of my value, How much did I lose? It would have been 2% because 1 minus 98 is 2. So this should have said 2% each month. I know that if you look at the original problem, it says 0.81. So if you did 1 minus 0.81, you do get 0.19, which is 19%. However, this is given to you as a yearly rate. That's how much you lose each year. That's the other reason it's wrong. Number 11, what is true about the end behavior of 2 to the x plus 4? You could sketch this by hand. It's an exponential function that is shifted up 4 units, or you could put it into the calculator. 2 caret x minus 4, plus 4. Now, if you put that in the calculator, you can see the graph looks like this. And our end behavior always starts with as x goes to positive infinity, what happens? So as x goes to positive infinity, here's your x-axis and positive infinity. The function is going up, 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 up. So the function y is going to positive infinity. You can cross off choice 1 and choice 4. Now, what's happening as x goes to negative infinity? As x goes to negative infinity, this was our special exponential function. As we go to negative infinity, the function isn't going up or down. It's sort of leveling out right here at the asymptote. And the asymptote of that function, pardon those big green dots, is 4. So as x goes to negative infinity, the function is approaching 4. Okay, that was the major difference between our exponential graphs and our logarithmic graphs. I didn't mean to say logarithmic, our polynomial graphs. Okay, so as we approached negative infinity on the x-axis, we did not go up and down here, we leveled out. And that leveling occurred at the exponent. All right, number 12, frequently missed. Using the properties of rational exponents, determine the value of y. All right, let's take a look at what they give us. X to the 4/3 squared over the cubed root of x. Well, if you have a power to a power, you're supposed to multiply. Make this 2 over 1. 4 times 2 in the numerator is 8. 3 times 1 in the denominator is 3. So the top of your fraction is x to the 8/3. Let's rewrite the bottom using IO, inside over outside. X to the 1/3. Now, when you have division, you subtract exponents when the bases are the same. 8/3 minus 1/3, they have a common denominator of 3. So 8 minus 1 is 7. That's what that problem equals. That's wonderful, but I don't want that. I want to know what is y. Now take a look over here. Y is in the exponent. So my answer here is y equals 7/3. I just wanted to know the exponent. Number 13, rewrite using only positive exponents. 12 has an exponent of 1, so I'm leaving it alone. 24 has an exponent of 1, so I'm leaving it alone. If I change this up, x to the negative 5 is in the numerator. If I want to change the sign of the exponent, I reciprocate, put it in the denominator. Y to the 5th has a positive exponent. Leave it alone. In the denominator, x to the negative 3. I want to make that exponent positive, reciprocate, put it in the numerator. Y to the negative 2. Want to make that exponent positive, reciprocate, put it in the numerator. So what you're left with is 12 divided by 24. 12 goes into 12 once, 12 goes into 24 twice, times y to the 5th times y squared times x cubed over x to the 5th, which is 1/2 y to the 7th x cubed over x to the 5th. When you divide, you subtract exponents. So I'm just going to get rid of the 1 in the numerator. You don't need to write 1. So I have y to the 7th x to the negative 2 over 2, because 3 minus 5 is negative 2. But since they wanted positive exponents, this is y to the 7th over 2x squared. You don't need to show me every single step here. I did all of them out like this to just show you one method. Another way to do this problem would be to just divide immediately. So 12 over 24 can stay, but x to the negative 5 minus x to the negative 3 is x to the negative 2, because when you divide, you subtract exponents, and negative 3 minus negative 5 minus a negative 3 is negative 2. And with the y's, 5 minus a negative 2 is 7, which simplifies to y to the 7th over 2x squared in the denominator. Okay, again, I just divided 12 into 12 and 12 into 24. And then I brought down this negative 2 to make the exponent positive like they wanted. Number 14, solve for x. When you solve for x here, guys, you need to subtract 40 first. And you get 3x to the negative 3 halves equals 81. Then you need to divide by 3 because only x has that exponent. 3 does not have an exponent on it, so you need to get x all the way by itself. Now you can reciprocate the exponent, raised to the reciprocal power, which is negative 2/3. And if you put that into your calculator, you're going to get 1/9. Okay, so the common mistake here was, one, you tried to get common bases, but x cannot be a common base, and 2, you forgot to divide by 3. You aren't going to get any credit just for subtracting 40. That's like a given part of the problem. They need to give you a point for isolating x all the way, so what I wrote in this last blue line right here will get you a point, and raising to the reciprocal power to get your answer will get you your second point. Number 15, if $1,000 is invested at a rate of 4%, compounded continuously, the compounded continuous formula is A equals P e to the exponent RT. What is the value in 5 years? 1,000 is your initial value, so that's P. The rate is R as a decimal 0.04. And the T is time, 5 years. If you didn't know your formula, you got this wrong. P is 1,000 times E is on your calculator to the R 0.04 times T. You just had to plug that in. But if you didn't have your formula, you couldn't have just plugged it in and gotten it right away. So I'm going to go to the calculator and do 1,000. Second division gives me E. Caret for the exponent, 0.04 times 5. They wanted to the nearest dollar, so this 1,221.4 became $1,221. It is super easy if you know the formula. It's very difficult to get full credit if you don't. The common mistake you guys did on that was you tried to do P times 1 plus R to the T, which is similar, but it's not going to give you the same answer because that's compounded annually, where n is 1. This is saying continuously. Whenever it says continuously, you have to use the PERT formula. Number 16, rewrite in the form k times x to the n. Okay, how do I make that exponent positive? I put the entire piece in the denominator. Now I've got 1 over 2 cubed, which is 8, and x cubed, which is x cubed. But they want this form, so they want the 1/8 all by itself out front. And then they want that multiplied by x. X cannot be in the denominator. Based on that form, it says k times x to the n. So this is times x, if you want that in the numerator, to the negative 1/3. I'm sorry, to the negative third. Now another way to do this would be to distribute the 3 right away. So you have 2 to the negative 3, x to the negative 3. And then put 2 to the negative 3 in the calculator and get 1/8. Keep the x to the negative 3. Whatever you want to do is fine. Number 17. Explain how this can be rewritten as that. Explain means use your words. So we have 3 to the 1/5 squared, which most of you guys wrote right away with the power rule as 3 to the 2/5. And then you rewrote it, making that 3 squared, or the 5th root of 3 squared, which is the 5th root of 9. That'll get you 1 point because that's the math behind it. But in words, you would have to say something like, I used the power rule to make the exponent 2/5. I raised 3 to the 2nd power and took the 5th root. Or wrote the 5th root, which would be the 5th root of 9. Something like that. You can't just say I did the math or anything like that. You have to be a little bit more specific. 18 is another question that says explain, so in words. Now, using the unit circle, so you know from when we first did trig, the unit circle, the value of cosine theta is equal to x. So here we go. On the unit circle, cosine theta equals x. Since secant theta equals 1 over cosine theta, secant theta equals 1 over x. Okay? Or you could have said secant is the reciprocal of cosine. Doesn't have to be word for word what I wrote. And the last question for this video that we're going to go over is question number 19. 19 was worth 4 points. The first thing you had to do was change the base in the top equation to also be a base of 2. So I made 8 2 cubed. Once I do that, I have the common base of 2, and the equation that results is 3x equals 3 times 2y plus 1, or 3x equals 6y plus 3 when you distribute. You then have to change the bottom equation. 9 can be written as 3 squared. So you're left with 3 squared to the 2y power equals 3 to the 3x minus 9. Where, now that the bases are both the same, 3, you're left with 4y when you multiply equals 3x minus 9. So you have two equations, equation 1 and equation 2. What you need to do is make both of those equations into something where you can perform elimination. So I'm going to put x and y on the both on the same side by subtracting 6y. My new equation is 3x minus 6y equals 3. That's my first equation. My second equation is 4y equals 3x minus 9. And again, I want to put the 3x and the 4y on the same side. So if I subtract 3x on both sides, I get negative 3x plus 4y equals negative 9. After I have my two equations, I'm going to solve with elimination. So if I write those equations on top of each other, what you may notice is that you can eliminate right away. The coefficients on the x terms are additive inverses of one another. So if you add those two equations, x eliminates. Negative 6 plus 4 is negative 2. And 3 plus negative 9 is negative 6. So to solve, divide by negative 2, and you're left with y is equal to 3. The last step is to solve for y. Y can be found by plugging in x to either of your original equations. So 3x is equal to 6 times 3 plus 3. 3x is equal to 21. And dividing by 3, you get x is equal to 7. So your final answer here as a point of intersection is the point 3, 7. Nope, lying. Points are written as x comma y. So your final answer is the point 7 comma 3. I'm not doing the last problem again because the last problem was already on your Edmodo as a YouTube video. I did that same exact problem as a video. So if you weren't able to do that, click on the link in Edmodo on YouTube for the 6-point exponential equation. Once you feel comfortable when you've watched these, you can watch them again while you're doing the worksheet of similar problems. The worksheet is due Monday when you come back from break. There are no exceptions to that deadline. So if you are willing to do it ahead of time and you get it in class on time that Monday, I will give you a 10 out of 10 on a test, which will help you out. Thank you very much. Have a great weekend.